have to know that one of those numbers was equal to 0, right? Or both of them. So that's what this is saying, right? So if a times b equals 0, one or both of the numbers is equal to 0. And so what we can do with this is that if the product of two or more unknown quantities is equal to 0, then all the factors can be set equal to 0. This is really the part we're going to be using here to help us. All those factors are going to be set equal to 0 in order to solve and find those solutions to the original equation. So essentially what it's saying is that we can take the factors of a problem and set those equal to 0, and then thus be able to find the solutions to that equation. So this problem's already factored. So we just take each factor and set it equal to 0. So I would say, 2x minus 1 equals 0. We'd also say that x plus 3 equals 0. And of course, solving that second one, just subtract 3 over. So I get x equals negative 3. Solving the first one, we would add 1 over, and then we would divide by 2. So we get x equals 1/2. So again, that problem was already factored, so we just got to move straight into the solving part of it. Normally the problems won't be factored already, like B or C here. We do want to make note of whether or not the problem is equal to 0 or not. Okay? It does need to equal 0. Okay? So making sure that that's there or not. So noticing that the first problem is set equal to 0, or the second problem is set equal to 0, so we don't need to worry about that. So we need to factor that in order to move along. So we should kind of run it through our factoring skills and say, well, what type of factoring should we always try first? And that would always be, is there a GCF? Right? And so, yes, there is a GCF here. So let's take that greatest common factor out, which would be x, and the x times x minus 5. And it's still equal to 0. Don't get lazy and drop that off. Okay. And we should be asking ourselves, is there more factoring that I need to do? So we've taken that out. Is there something else I could have taken out with that? Right? Did I actually take out the GCF, or did I leave something in that I didn't notice? Well, these two things don't have anything in common. Okay, so no more GCF. But is there other types of factoring I need to worry about? And so what I should be looking at is there more x's? Right? How many? If I don't have a higher power of x, then I can't have multiplication. Right? Factors is about what's multiplied, and if it's just x, I can't have anything multiplied to be x besides just 1 and x. So if it's at x squared minus 5 or something like that, then I need to worry, is this still factorable? So since there's not a higher power or anything left in common, I am done factoring at that point, which means we can move on to the second part of the problem, which is to set each factor equal to 0. And then solve. And of course, that blue one is already solved. Second one, the purple one is the easy solution. X equals 5 once we move the 5 over. Again, we get our two solutions, which we should have been expecting because the fundamental theorem of algebra says, hey, there's going to be two answers to this problem. Okay. We may not see that square that we see here, but remember this problem is already factored. We went backwards a step and say, where did this problem come from? These would have been multiplied, and that would have been a 2x squared. And x squared would have given us, told us that there was two answers again. So, right? So you should always be expecting two answers on these. This problem is not set equal to 0, so I'm going to add that 8 to the other side first. X squared minus 6x plus 8 equals 0. And then we want to run through our factoring skills, right? So can I factor that by GCF? And those three things don't have anything in common, so no, right? But you should then notice that there's three terms. And so if there's three terms, what factoring method should we use for three terms? What factoring method should we use for three terms? Right, Rhea, AC. So now that we know that we're doing AC method, it starts with a question to yourself. How do we start the AC method? Or actually, there's something else we could notice about this problem that tells us something about the AC method that we need to do. It's something we need to notice about this problem, or what's the first step? So why can we do simple AC, Rhea? Yep, A is 1, right? So our A value is 1. So that leads us to know that we can do the shortcut. So again, I call it simple AC or easy AC or shortcut AC. I know Miss O'Neill called it the I am method. Okay, so but still that idea that because A is 1, we can do this in a faster way. So now we're just knowing that, but we still need to be figuring something out about this. What's our question? Or what's our first step? How do we start AC method? That's the first thing we need to do. We went through GCF. There wasn't a GCF. Factors of 8 equal -6. There you go. All right. So where did you get that 8 from, Rhea? You're oversimplifying a little bit. It's called the AC method for a reason. I know, and we know A is 1, so we still need to figure out that, right? A times C is equal to 8, and we need those to add to -6. And so Grant, the question you should be asking yourself is, what factors of 8 add to be -6? So of course, 1 times 8 is 8, and 2 times 4 is 8. So how are we going to get -6? And -4, -2, right, Grant? Now, because this is shortcut, we can go straight to the answers, right? X minus 2 times x minus 4 equals 0, right? Remember, that only works for certain problems. So I just want to go back over a full AC method because it's been a little while since we've seen it. What you really should be doing with those is saying, well, that means that x squared minus 2x minus 4x plus 8 equals 0. Don't lose that equals 0. Right? The idea here is that we're taking that -6 and we're breaking it apart in a very special way. And so those two numbers multiply to be 8 times 1 and add to be -6. And then once we do that, we can break the problem in half and say, okay, well, those both have an x in them. Now we're doing that GCF. I don't know if that's what you're referring to, Grant, or not. And those both have a -4 in them. And then you finish it up by going into here, right? So what the shortcut AC method allows us to do is to skip those two lines of work, right? Because A is 1, I don't need to do all this, because every time A is 1, these two numbers show up here, right? So if we notice that pattern, then we can skip all this other stuff. When A is not 1, these two numbers don't show up here, so we have to go through all this stuff, okay? So it's just taking advantage of that. Every time A is 1, those two numbers end up right here again, so why bother doing all this other stuff? We're just going to see those numbers again. Of course, if x minus 2 equals 0, then x must equal 2. And if x minus 4 equals 0, then x must equal 4. X must equal 4. Anything about solving by factoring you guys want to talk about? It's GCF factoring, AC method factoring, maybe difference of squares. There's no crazy factoring that you should worry about. Okay. The next method, solving using radicals or solving using square roots. You do want to make sure that when you guys are doing your work, that you're preparing yourself for the test in the way that if I'm saying, or if the book, the Web of Science is saying use a particular method, make sure you're using the method they're asking. Some of the problems can be done with multiple methods. I want you to be prepared to show me a particular method, when I ask you to. So, just to that point, I could do A here by factoring. I can solve this one by factoring. I'll show you real quick what that looks like. But then I'll of course show you the other method. So if I solve this by factoring, set it equal to 0. I say, well, how do I factor this? Well, there's no GCF. I could technically do the AC method here, but we know a shortcut on the AC method for problems that look like this. Right? The last one we said, well, as long as A is 1, there's a shortcut there. Well, and even more specifically, if the problem looks like this is just difference of squares factoring. So now it's x minus 3 times x plus 3 equals 0. And then, of course, x would equal positive 3, and then x would equal negative 3. But if we looked at a problem like B and said, hey, let's solve that one by factoring, right? And so I say, well, negative 3x squared minus 12 equals 0. Say, okay, we'll start with the GCF. They both have a negative 3 in them, so I take that out. That leaves me with x squared plus 4. Right? X squared plus 4 is not down to being just an x. I can't tell what x is here because this plus this equals 0. This is not factorable anymore. So if I can't factor it, then I can't set the factors equal to 0. Just don't make that mistake that thinking that x squared plus x plus 2 squared does not equal x squared plus 4. So if it's not factorable, we can't set the factors equal to 0, then we can't continue to solve, right? So that method doesn't work for this problem, right? We need to have a different way of attacking it. There's something fundamentally different about these 3 problems here than the last 3 that we did. What that is that there's literally only one x in this problem. Okay? Mathematically, there's 2 x's in this problem, but literally there's only one x in this problem. Same thing here. Literally only one x. Literally only one x. Well, if there's only one x in the problem, that x can be isolated. So our job is going to be isolate that variable. Okay? Just like you learned way back in Algebra 1 or in pre-algebra, how do I solve a linear equation? Well, let's get the x by itself, right? How do we do that? Okay. Well, when there's not one x, right, when there's 2 different types of x's, I can't get x by itself. So we had to have a different way of solving this. Okay. Both of these problems have multiple x's in them. Again, this problem has multiple x's, even though they look like they're the same type. Remember, it's already been factored. Where it came from had different types of x's in it. So when there's multiple types of x's in the problem, solving by factoring is the way to go. When there's one type of x in the problem, you can just solve it by using radicals or a more standard isolate the variable type idea. So if we can isolate the square variable on one side and we want to set it equal to a constant, so not 0, on the other side, then the equation will be solved by taking the square root of both sides. And as long as we put plus minus, I know that's something that we've talked about. You got to put a plus minus when you're doing that square rooting. So the method that we should be using here, I want to get x by itself. So I'm going to start by adding 9 to both sides. And then once that power group is isolated, we square root both sides. So on the left it gives us x. Now because we square rooted, we need to address that fact that there's 2 answers to that question. What number multiplied by itself is 9? Well, there's 2 numbers and I can multiply them by themselves to get 9, positive 3 and negative 3. Okay? So just remember there's a difference between me asking you this, what's the square root of 36? Okay, and then x squared equals 36. Those are 2 different questions. And the square root of 36 is just 6. What number squared is 36 has 2 answers. I could square 6, or I could square negative 6 and get 36. Okay? So 1 answer, 2 answers. If I want the negative version of this, I would have to say, what's the negative square root of 36? That would equal negative 6. Okay? Again, only 1 answer though. Or the fundamental theorem of algebra says this equation has 2 answers. So you gotta make sure you address that here. Same idea here, we want to get x by itself. So I'm going to add 12 to both sides first. Still trying to get x by itself, I'm going to divide by negative 3. And then since I'm down to the power part, I can get rid of it by square rooting. So x equals, and as soon as I square root both sides, the plus minus needs to show up. Okay. Very, very common mistake to make, to forget to do that. You don't want to do that. So plus minus the square root of negative 4. Well, what's the square root of negative 4? What number do we multiply by itself to get negative 4? Two times 2 is negative 4? What number do we multiply by itself to get negative 4? Are you saying to multiply 2 times negative 2, Grant? Okay, but that's not multiplying a number by itself. Squaring means to multiply a number by itself. Okay, guys, what's the square root of negative 4? We can. I'm not asking you to do the impossible here. Katie, what's the square root of negative 4? Marlo, what's the square root of negative 4? Wesley, what's the square root of negative 4? Say it loud, Maddie. Nobody else can hear you.
Is it 2i?
2i. What's that mean? What's 2i mean?
I don't know. I just looked ahead in our notes, and I we were doing the eyes.
What's I mean, guys? Yeah, right. It's an imaginary number. Right? There's no real square root of negative 36, but there is an imaginary square root of negative 36. So Grant, what's the square root of negative 36?
A6i.
So, Cole, what's the square root of negative 25? I want negative 25, not 5. 25. Angelique, what's the square root of negative 49? Wesley, what's the square root of negative 100? Cole, what's the square root of negative 25? Cole.
-5.
Come on, Cole. Get all these other answers here, man.
5i.
There you go. Yep. The square roots of negatives are imaginary. You guys won't be doing a lot with this today. We'll get more into it tomorrow with I, but if there's anything that deals with it, it'll be a very simple one like this: the square root of negative 4, the square root of negative 16, the square root, negative 9, something like that. So, okay. And if you did have to type this in to WebAssign, you'd have to type x equals 2i and then x equal, or then comma like negative 2i, be like that. Okay. Since there's no plus minus button in WebAssign, so it would just ask you guys for a comma separated list. Okay. Last one of these, more complex problem. You really want to avoid the fairly common mistake of doing what it says, right? Looking at that and saying, I need to simplify that left-hand side. I need to write out x plus 3 twice, and I need to FOIL it out, and then I need to distribute the 2, and then I need to, combine the like terms with the 10. Like, you do not want to do what it says. You need to be focused on undoing, right? Our goal here is to isolate x, okay? How do we get x by itself? And then our tool for that, to help us along that, is to follow a SADMEP. We've been doing this whole time. I just didn't mention it, right? We were getting rid of subtraction, addition first. We were getting rid of, division, multiplication next. Then we're getting rid of the exponents next. Okay? So you're following SADMEP to make sure you're undoing the problem in the right order. So again, focus on undoing. Don't do. If you start foiling and distributing, you're going to make the problem way harder. Okay. So if I want to undo, I want to get rid of any subtraction addition first. That's going to make that 10 needs to go away. So we get 2 times x plus 3 squared equals 10. Any division multiplication I can get rid of, right? Let's get rid of that 2. X plus 3 squared equals 5. Any exponents we can get rid of. And let's get rid of that square. So on the left-hand side, the square goes away, which means there's nothing on the outside of the parentheses, so the parentheses can go away. Because we just square rooted both sides, we have to put the plus minus in there. Again, very commonplace for mistakes right there at that step. Okay. And so like I said, the parentheses are gone now. But x still isn't by itself, which means we head back up the ladder and say, well, what's the next thing I can do? Oh, I've got some subtraction and addition I can do again. So I'm going to subtract 3 from both sides. So as I do that, what you don't want to do would be to put it back here. Okay, we don't want the problem to say this. Okay, and the reason we don't want that is because if you get sloppy with that radical, it gets really unclear where that 3 is. Is it under the radical? Is it not under the radical? I can't tell. Okay, so we don't do that. It goes in front of all that stuff. Okay. And what we don't want to do is we don't want to put it there, okay, because that would be plus minus negative 3 square root of 5. And what that means is negative 3 times the square root of 5. This isn't multiplication, this is subtraction. That's not what this says now, so I can't go there. So I don't put it after the radical, I don't put it right before the radical. Okay, it goes in front of the plus minus. So there's our 2 answers. And again, how you would type that into WebAssign would be negative 3 plus the square root of 5, comma. Oh, that's fun. It's actually the first time that's happened today. So that's how you would type those 2 answers. Okay. Again, if you're writing it out for me, that's good enough. For the computer, it needs to see it that way. Again, these are not imaginary numbers. That's not a square root of a negative. Those are irrational numbers. Those are numbers that never end as far as decimals goes. The decimals never repeat, they never end. Okay? So they are real numbers. They're just not something that we would have a good concept of. So if I said, if I tried to tell you that, to graph that point or something like that, it would be difficult. Okay? If we wanted to do that, we would have to get some sort of decimal approximation of that. So the square root of 5 is about 2.2-ish. So if we think about negative 3 plus 2.2 would be about negative 0.8. And then negative 3 minus 2.2 would be about negative 5.2. So that's the value of those numbers. They are real. They're just irrational, never-ending, never-repeating decimals. So. Any questions about using square roots to solve?
Mr. Baker,
Yep.
How do you know if you need to do square roots or if you don't?
Most likely, like on the homework, it'll tell you. Most likely on the test, I'll tell you. I very well could just say, here's a problem, solve it, and then leave that up to you. We could, like example A there, could have been solved by factoring, could have been solved by square roots. It also could have been solved using the quadratic formula. All right, so we could have done any method on that one. Usually in that type of situation, Maddie, it's what method's the easiest is really a question you should be asking yourself. Okay, the quadratic formula works for every problem, right? That's the design of that tool is that it solves every quadratic problem. But maybe if you remember using this analogy before, the quadratic formula is kind of the sledgehammer in your toolbox. It works all the time, but we know what the quadratic formula looks like. It's a messy problem. So there's no way I would look at a problem like this and say, oh, I should use the quadratic formula to solve that. It would be 5 times the amount of work. Both of these were pretty simple. I wouldn't say one versus the other was any easier. This problem wasn't factorable, so I couldn't factor it. I could use the quadratic formula though, but again, this was a lot less work than the quadratic formula was. This would not have been factorable. It was also, if I had to do the quadratic formula, then I would have had to do all that simplifying first, because this is not in standard form. So that would be a way of saying, oh, I should definitely not do the quadratic formula because I have to do all that work, and then I have to do all the quadratic formula work. I should just do square roots instead. The other thing I said was, remember, if there's literally one x in the problem, square roots is probably your way to go. Right? There's only one x in this problem. There's only one x in this problem. There's only one x in this problem. Square roots is probably the easiest. Again, this one, pretty much the same amount of work. If there's multiple types of x's in the problem, right, an x squared and an x, there's no way to square root that. I have to factor it, or the quadratic form. So, does that help at all? Right now, I would just focus on doing what it says. They're not going to just throw a problem at you and say, do this. They're going to say, use this method to do it.
Yeah, that makes sense.
I don't think I'll just throw a problem and let you guys figure it out. I'd rather see that you can use the particular methods. Yeah, it's a lot to consider. Sorry, I'm trying to get rid of something I wrote on here. Accident. Yeah, there's a lot of little things you have to pay attention to that are kind of the clues. Like, what are the little markers I should pay attention to let me know what's the path through this problem? And I think the big one again is, are there multiple types of x's or not? If not, get it by itself. If so, factoring. If unfactorable, quadratic formula. So. Any other questions? Let's go to Maddie. Well, let's do one quadratic formula. I know we were working on that, a couple weeks ago. Let's bring it back. You guys are gonna have to flip 1, 2, 3 pages in your notes. So you should notice the one that says projectile motion. We're not going to be doing that, but it's this problem right here that we're going to do. But it's probably easiest to find this thing. That's what we were just doing with the quadratic formula, was using it for projectile motion. You guys all find this problem? Okay. So we're going to do that problem. We are not going to do the discriminant stuff, just to save some time to talk about all that junk. So we're just going to be finding the solutions using the quadratic formula. That's all we're doing. Of course, it would help if we know the quadratic formula. Negative b plus or minus square root negative b squared minus 4ac all over 2a. Kind of two things that have to be there. It's got to be equal to 0, and it's got to be in standard form. So kind of like I was talking about with Maddie on that very last problem that we did, was not in standard form. We could not have done the quadratic formula until we worked to get it there. So it needs to go x squared, x constant, equal to 0. If there's no b term, you can use 0 for b. If there's no c term, you can use 0 for c. You cannot use 0 for a. So if there's no a term, then you shouldn't be doing this anyways. This problem is in standard form. It's equal to 0. So a equals 3, b equals negative 7, c equals negative 5. Okay, why is it doing this much? Yeah, I'm a big fan of the setting up the problem with all the pieces and then going back and filling in all the new information. So I know I need a negative something. I know I need something squared. I know I need -4 times something times something. All over my 2a, 2 something. I need a -b, so that's going to go here. I also need a b there. And I need a value here and here. And that c value. Last time we did this, we were looking for something different. We were using this in an application sense, and so if we got down to an answer that said like 3 plus the square root of 5 seconds, okay, you need to wait 3 plus the square root of 5 seconds for that ball to hit the ground, and that doesn't make sense. Even though that's a real number, we don't know how to make sense of 3 plus the square root of 5 seconds. So we were using our calculators to get decimals, right? Get those approximate answers out of that. We're not doing that right now. This is not an application problem. This is purely a solving problem. So we want the exact answers, which means your answers need to be in radical form. Which really means you probably should just be doing most of this by hand. Start with the simple stuff. Those things right there should be the easiest things to deal with on your own. So -7 is +7 plus or minus the square root of something all over 6. And then you look at that square. How many times I've seen people mess up that square, -7 squared. Okay? You should know by now that squares are always positive. 7 times 7 is 49. -7 times -7 is also 49. It's not -49. I've seen so many people mess that up. And then next thing is this. What I would notice about that is that there's 2 negatives, right? A -4 and a -5, which means that this is going to be a plus sign here. And 4 times 3 is 12, 12 times 5 is 60. So I get plus 60 out of that. Which equals 7 plus or minus the square root 109 over 6. And then technically you should take this square root of 109 and try to sock that out. So I'm saying, well, what's 109 divided by 3? What's 109 divided by, I'm not going to divide by 5 because it's definitely not divided by 5. And what's 109 divided by 7? What's 109 divided by 11? What's 109 divided by 13? Seeing if that's some number that's multiplied, if it's got factors. 109 turns out to be prime, so there's no sock on that. So essentially we are actually done at that point. There's nothing else I can do. I don't think, from what I saw from the problems in the WebAssign, that there is any reducing you guys will need to do. These are pretty basic quadratic formula problems. So there's our answers. There's our 2 answers. Okay? Again, you guys have to type that into the WebAssign. So it wants that as x equals 7 plus square root of 109 divided by 6, comma, 7 minus square root of 109 divided by 6. That's the way I'll have to type it in.